So for number 33, they want us to take these two curves, y is equal to e to the x, the one that's in red, and square root of x plus 1, and then revolve the area bounded between them, so this little section here, about the y-axis. And so the first thing that they tell us is to use a graph to estimate the x-coordinates of the points of intersection, and that when I used the graph and I saw the points here, it would be at x is equal to 0, that's one value, and x is equal to 0.56 approximately. And the reason that they want us to use a graph to find these points is if you were to take these equations and set them equal to each other so that you can find where they intersect, you would have a really hard time seeing where they're going to match up beyond the point x is equal to 0, beyond this first one. The second one would be really hard for you to find. So once we've put that in our in the graph, we can see here that the boundaries are going to go, our volume is going to go from 0 all the way to 0.56. So that's our boundaries. And now we have to think about what happens when we revolve the section about the y-axis. So what's going to happen is we're going to have the difference between their heights is going to be revolved like so, and this is going to give us a cylinder, right? And so if we think about taking the cylinder and then unwrapping it as though it were a thin sheet of paper that got wrapped around the y-axis, this sheet, it has an area, right? And it is an area as a function of x, because like the further that we move on the x-axis, so the further that we move on horizontally, the wider that my cylinders are going to get, but also smaller in height, right? So this definitely does change as a function of x. And now all we have to think about is how do we express this in x? Because if we can express it, then our volume is going to be the sum of all these areas, right? And we're summing them up horizontally. So let's think about it. Well, the first part here, which is this height that gets revolved, this one's pretty easy because as we can see, it's just the height of the blue curve minus the height of the red curve. So when we subtract, we get this little section here. So it's going to be the height of the blue curve, so square root of x plus 1 minus the height of the red curve, so minus e to the x. So that is our height. Now, what about our base here? Because area is equal to base times height, right, in our rectangle. And so we can see here that the base is just going to be the base of the cylinder. It's just going to be a circumference. And now any circumference is given by 2 pi r, and we just have to express this r in terms of x because we are integrating with respect to x. So let's think about how we're going to do that. Well, take this point here, which is maybe about at 0.1, 0.2, at 0.2 on the x-axis. Well, this radius is just going to go from 0 all the way out to 0.2, right, or wherever that is. If I'm at this point here, which is maybe 0.4 something, that radius is going to go from 0 all the way out to 0.4. So we can see here that the radius of the circumference is just the value of x, right? So this is just going to be 2 pi x, because that's the circumference where the radius is x. Therefore, our area is going to be base times height is going to be 2 pi x times square root of x plus 1 minus e to the x. So that's our expression for the area, and it just means that wherever we're at on the x-axis, if we plug the value of x into this expression, this is going to give us the area of the cylinder that encloses it, right? So if I plug in maybe around 0.4, so that's this point here, it's going to give me the area of this cylinder right here. And so to find the volume, I'm just summing these up, right? So wherever I had a of x, I'm just going to now replace it with my expression for it. So that is, let's see, 2 pi x times square root of the x plus 1 minus e to the x, and all of this times the x. And then they're asking us to use a calculator, right, to resolve this integral. They don't want us to do it analytically by hand. And so if you plug this into a calculator that can integrate, I like to use the online one called Symbolab. This is going to give us approximately 0.13. And so that's the volume that we get when we take this area and we revolve it about the y-axis.